If you run applications on Kubernetes, you already know that security can be both critical and chaotic. Containers are created and destroyed in seconds. Microservices talk across namespaces and clusters. Cloud infrastructure spans AWS, Azure, and Google Cloud. The challenge is protecting everything without slowing delivery. In this review, we examine ARMO, a Kubernetes-focused security platform that introduces Cloud Application Detection and Response, or CADR, and we explain how it differs from traditional cloud security approaches. Let's start with what ARMO is. ARMO is a cloud-native security company built for Kubernetes from the ground up. The team behind ARMO created Kubescape, an open-source tool widely adopted by the community to validate Kubernetes clusters against best practices, including guidance from the NSA-CISA Kubernetes hardening recommendations. Kubescape helped many teams gain initial visibility into misconfigurations, RBAC exposures, and policy gaps. The commercial ARMO platform expands this visibility into runtime detection, risk prioritization, supply chain validation, and guardrails that prevent risky deployments. The center of ARMO's strategy is CADR, Cloud Application Detection and Response. Think of CADR as a focused, Kubernetes-aware counterpart to broader detection and response systems. Rather than collecting generic cloud logs and producing thousands of alerts, CADR ties together Kubernetes context, pods, services, deployments, namespaces, and cluster roles with runtime activity, image vulnerabilities, and network flows. This correlation highlights what is exploitable now and what matters to your applications. A frequent buyer question is whether ARMO uses AI. ARMO emphasizes deterministic, context-driven analytics and rules built around Kubernetes semantics. Where anomaly detection can help, the platform can baseline behavior and surface unusual process or network activity, but the value does not depend on opaque machine learning. The practical win for most teams is reduced noise, fewer theoretical findings, and more issues that are reachable and exploitable within the present cluster topology. How does this compare to CNAPP and CSPM? CNAPP is a broad category that often includes cloud workload protection, posture management, data security, and identity analysis across virtual machines, containers, serverless functions, and cloud services. CSPM focuses on configuration and compliance for cloud accounts and services. These platforms are wide, but not always deep in Kubernetes internals. ARMO narrows its focus to Kubernetes and delivers depth. Runtime decisions map to your services, prioritized by exposure paths like internet-facing ingress, service-to-service trust boundaries, and privileges defined in RBAC. Many organizations pair ARMO with a CNAPP for non-Kubernetes assets or overall cloud account posture, while relying on ARMO to secure cluster-native applications. Let's break down the main capabilities. First, posture management that is native to Kubernetes. ARMO evaluates cluster configuration, RBAC, network policies, and workload settings against frameworks such as NSA-CISA and industry best practices. It can ingest image scan results and SBOMs to illuminate known vulnerabilities in the context of running services. Second, runtime security that correlates signals from Kubernetes audit logs, workload metadata, and container runtime events to detect suspicious behavior like unexpected process execution, privilege escalations, or lateral movement attempts. Third, admission control that enforces policy as code at deploy time, so high-risk images, missing runtime permissions, or failing checks do not reach production clusters. Supply chain risk is another core pillar. ARMO connects image scanning with SBOM awareness to identify vulnerabilities and license risks. It then maps those findings onto actual workloads, namespaces, and ingress paths, so your team can prioritize remediation on packages that are running in internet-exposed services first. By bringing supply chain data, deploy time policy, and runtime behavior together, ARMO closes the loop from code to cluster to live traffic. Integration and workflow fit are often the deciding factors for platform teams. ARMO typically integrates with CI/CD systems like GitHub Actions, GitLab CI, and Jenkins to run checks pre-deployment. Findings and events can be exported to SIEM and observability tools such as Splunk, Datadog, and Elastic for centralized monitoring. For ticketing and collaboration, security tasks can flow into Jira or similar tools. This keeps security action close to the developers and SREs who will fix the issues. Coverage matters just as much. ARMO supports managed Kubernetes services, including Amazon EKS, Azure AKS, and Google Kubernetes Engine, as well as self-managed clusters on premises or in private clouds. Organizations can mix agent-based options for deep runtime visibility with agentless data sources where installation is constrained. The onboarding path is straightforward. Connect a cluster, let the platform inventory namespaces, workloads, and configurations, ingest image and SBOM data, and begin correlating runtime signals. Early insights often include misconfigured RBAC roles, workloads that run with elevated privileges, and internet-exposed services mapped to vulnerable images. Let's address common concerns. Will ARMO slow down deployments? With policy as code and admission control, the idea is to shift checks left and fail fast on risky deployments, which can accelerate delivery over time by preventing late-stage rollbacks and incidents. Can ARMO replace my CNAPP? If your environment is primarily Kubernetes, ARMO may cover most needs. If you also have VMs, serverless, and extensive cloud-native services, a complementary CNAPP or CSPM may still be useful. Does ARMO require deep Kubernetes expertise? The platform surfaces context in plain language, with service maps, prioritized risk views, and guided fixes. But Kubernetes fundamentals still help your team get maximum value. How should you evaluate ARMO? In a proof of value, measure time to first meaningful finding, the reduction in non-actionable alerts, and the percentage of issues tied to running exposed workloads. Track mean time to detect and mean time to remediate across a sprint. Verify that admission policies block the classes of risk you care about without excessive false positives. Ensure integration with your CI/CD, SIEM, and ticketing workflows is smooth and does not create tool sprawl. What about cost and operations? Pricing and deployment choices vary by organization size, number of clusters or nodes, and features. Consider the operational overhead of agents if you choose them for deeper runtime visibility, and weigh that against the benefits of higher fidelity detection. Also plan for policy management as code, versioning, and review processes so that security guardrails evolve with your platform. Finally, who is ARMO best for? Platform engineering teams that run most workloads on Kubernetes and want runtime-aware security. Security teams that are overwhelmed by CNAPP and CSPM alert volume and need precise, actionable context for live services. DevSecOps organizations that prefer policy as code and integration with existing pipelines. If your core challenge is Kubernetes security with fast, frequent releases, ARMO's CADR approach offers a focused alternative to broad but shallow tools. In summary, ARMO takes a Kubernetes-first stance and concentrates on linking posture, supply chain, and runtime into one correlated view. CADR reduces noise by surfacing what is exploitable now instead of cataloging every theoretical risk. With integration into pipelines and monitoring stacks you already use, ARMO helps teams keep delivery speed high while giving security the runtime clarity it needs. If that balance is your goal, ARMO belongs on your shortlist for Kubernetes security.